Sorry about that, guys. I turned off my microphone. Yeah, so as I was saying, I'm here just having breakfast, and I'm just having some tea. Very good one. Yeah. Let's see if I can fix something by now at 3 o'clock. I want to fix that. I want to repair at least 3 computers if I can. All right, so I have this ThinkPad here that I want to repair. If I can repair it, let's see. All right, so this one is not turning on. All right, so I plug in the power. I'm not getting any current. The current is not fluctuating, no movements, not jumping, not fluctuating, nothing at all. All right, so let me remove these plastics. This is a ThinkPad T4. Let me check. It's a T420. I was checking it yesterday, but T450S. Yeah, T450. T450S. No power. Right, as you can see, this is a 5th gen Broadwell CPU, ULT, ultra low power. Right, so this is a Broadwell CPU, which is the 5th generation CPU of the low power of the core. This is most likely an i5. Can be an i3 as well, but definitely not an i7. All right, so I'm gonna check I was checking it yesterday, but because of time, I had to leave it. So I'm going to finish checking it now and see if I can repair it. All right, so I have standby 3 volts and 5 volt section here, I believe. I was checking. So the the PWM IC for this is TPS51220 or TPS51220, I believe. Let me go under the microscope. Can't see. Lights. Ouch. Alright, so it's a TPS. It's a bit difficult to see from this angle. TPS 51220. TPS 51220, and this is the standby chip, right? And I was checking the coils for it, corresponding coils, right? And I was getting good reading there. Yeah. All right, so this is the, so I checked CPU standby coils. Sorry. Yes, this is 3 and 5. All right, so I get 175 there on one. This one is the CPU core. I get 33. This is VCC. This should be RAM supply. 35 on this one. VCC 1.05. 1.05 for the VCC IO. 35. 244. I'll have to confirm with the schematic. Let me see if there's any coils under this side of the board, on the opposite side. I don't see any coils on the opposite side. So this should be for the RAM, and this is VCC IO. This is VCC CPU core, 1.8 volts. All right, and this is standby 3 volts and 5 volts, and they are all good. All right. All right, so this is the ThinkPad chip. As you can see, it's called the Think Engine, a very powerful chip. All right, it's called the Think Engine, as you can see, right? And this chip is a security chip as well, which is designed by Lenovo. Right, this is a newer version of the Think Engine chip. So this is what makes it typical an IBM computer system from IBM. This is the IBM typical design, right? So as you can see, the Think Engine, and the part number there is TBS TB623. Let me add some heat so I can see if we can get it clear. So it's TB62D 5S1 6FG. This is the ThinkPad chip, and this is the embedded controller chip. This is the embedded controller. There is the embedded controller, the SMC, right? MEC 1633L. So this is the EC, right? So this is the EC, and this is the ThinkPad chip, right? The Think Engine chip. All right, so first, this chip needs to work in order for it to communicate and to turn on the adapter and turn off the adapter. All right, the Think Engine chip here. All right, so I will have to get the schematic, and then I'm gonna check. Let me see if we are getting 19 volts on the board, because the DC power supply is not getting any current, not seeing any current jump in anything. So let me see if I am getting any 19 volts. Let's check on the standby section here. This is the upper MOSFET. Let me zoom out some more. All right, so this is the upper MOSFET. Oops, I'm on voltage. Right, so I'm getting 19.557 volts there, as you can see. Right, so I'm getting 19 volts. Am I getting 3 volts or 5 volts? No 3.3 volts, no 5 volts at none of the coils, right? I should be getting 3 volts and 5 volts here, right? So the standby chip should get some set of working conditions in order for it to produce 3.3 volts and 5 volts. Yeah. All right, so I'll get the schematic. All right, so let me see if I can find a schematic, and this board number as you can see is NMA 301. This is a Compal based motherboard which is designed by in Thailand by LCFC. Right, LCFC is the manufacturer, which is a Taiwan based motherboard. All right, so I'm going to check and see if I can find the schematic. Just checking my canvas here. Yeah. So it's NMA 301. All right, so let me head over to the schematic section. All right, so we need to find the chip, and that chip position number is that U101 there. Chip position number U101. So this is the first chip that you have to check when you're checking these ThinkPads, right? The Lenovo or the ThinkEngine chip. This is not my PDF file. I'm just hold on, let me just find this. View. Oh, here it is. All right, so it's U101. So we have U101. All right, so it's TB62D5F1. So this is the ThinkPad chip section here. And let me zoom in. So as you can see, this chip is a very powerful chip. It also communicates with the embedded controller because we have SL and the CPU. We have SLPS3, we have SLPS4, we have SLPS5, we have SLP LAN, we have SLPM, and we have source power acknowledgement. Yeah, so SLPS3 is from the PCH, SLPS4 is from the PCH. These are called ACPI control signals, right? Right, so ACPI stands for Advanced Configuration and Power Interface, right? And all these signals are sent from the PCH, as you can see, and it's coming to this ThinkPad engine chip to produce different power rails. So this chip is the key, right? We have backlight management, as you can see. We have backlight in, backlight out, right? We have GPU reset and other functions. So this chip is a very powerful chip. As you can see, it also has an SPI bus. So it's going to read the embedded BIOS chip here. See? We have chip select, right? See? ESPT chip select. Then we have clock, we have master out slave in, and MISOH master in slave out. Right, so that is the naming convention there, the abbreviation. Right, we have PLT reset. Right, and it is in two sections. That is A. All right, so we have U21A here, U101A, and we have a B. So this is the part that I'm interested in. So first we have to check if we are getting vint, V-I-N-T 0. All right, and this is coming from vint, and vint is coming from most likely the adapter. Select it. Oops. All right, and it's going to many places, as you can see. All right, that's not it. That's for the backlight. That's not it. This is coming to this is the same ThinkPad chip. All right, let's see here. Okay, so this is our isolation and protection. As you can see, DC in. So 19 volts is coming from pin number 3 and 4, right? As you can see. And is this a mark? All right, so you can't use this one. Oh, right. So it's coming from here, and this is the adapter, DC in, coming through this fuse, and it is become DC in underscore power underscore 20 underscore F, which stands for, this is 20 volts after passing this fuse, right? So this is a fuse of 7 amp, maximum 24 volts, right? And it's coming through this P channel MOSFET, which is Q9, and Q9 is also controlled by this ThinkPad engine chip, which is discharge, and we have power shutdown. So if you look here, we have a key signal which is coming from here, discharge. So when the battery is full and the embedded controller detects that and the Think engine, then it will send this signal high to turn on these MOSFETs and to discharge from battery. So it will cut off this MOSFET, right? This is called our adapter MOSFET, right? We have another MOSFET here, Q36, and after passing through Q36, it will do a full conduction and it will produce vint 20. So this is your common point voltage, right? This is our common point voltage. All right, so I'm going to check the working conditions of this ThinkPad chip. All right, so let me go back to the schematic. All right, so I'm going to go back one notch. So I'm going to check here if we're getting 20 volts. This is a shunt resistor which is acting as a protection, right? And this is basically limiting the current from here, and then it is charging this capacitor to filter out any clutter to give it a smooth 20 volts at all times, which is coming to pin 65. We also have another pin which is shutdown, which is the enable signal here, right? And it is pulled up by VCC 3SW. This is a linear voltage, and it is also controlled by the thermal shutdown signal, right? So shutdown should be high, as it's a pull-up signal which is coming to pin number 97, right, which is the shutdown pin. So we should get 3.3 volts here. Also here we have the thermal detection, right? There's no over temperature, and it's coming through these. As you know, we have RT1. These are called thermistors, right? These are all thermistors in a series, as you can see, right? These are all thermistors. So if any fault on this thermal detection series circuit, it will shut down, power shutdown. This voltage will not produce, and this power shutdown is going to use to turn on the next MOSFET. the next MOSFET, and it is also used as acting as a temperature detection signal to shut down the standby rails also. Right? Please bear that in mind. So this circuit is a very tricky circuit. Alright, I won't go in depth in this circuit. I'm just focusing on the basic working conditions to get the voltages that are required. Alright, so I'm going to check. As you can see for the standby chip, let me go to the standby chip, and it's TPS. Alright, 51220, I believe. Here is it. So first we have this is the TPS 51220. So first we have V in, right? V in, which is coming from the same VIN 20. We should check this first. Then secondly, we have an enable, which is coming from pin number 12 to turn on the LDO. So this is VREG 3 and this is VREG 5. Right, these are your LDO, very important. So 3.3 volts from here, and we have 5 volts LDO coming from here, pin number 29 and pin number 22. All right, so I'm going to check pin number 23, then I'm going to check pin number 12, then I'm going to check pin number 22 and pin number 29, right? These enable now are for the PWM output, right? Pin number 4 and pin number 21. So pin number 4, right? Pin number 4, if you follow this line, is coming from M on, and this is also coming from the ThinkPad engine chip. After getting the working conditions, if the working conditions are not met, this voltage will not come, right? And it will not turn on any 3 volts and enable PWM 5 volts. So this enable 2, as you can see, enable 2 is pin number 21. Follow the line, and it's also controlled by M on. So this is also these 2 enable signals are controlled by the Think engine chip. So I'm going to go back to the microscope, and I'm going to check the working conditions of the Think engine chip. So I'm going to go back to U101. All right, so I'm going to check the next part. So I'm going to check if I'm getting 20 volts at pin number 66. Also, we should get this voltage here, VREG 20, which is coming to pin number 100. This is coming through a voltage divider. This is 20 volts, and this is a 1.78 mega ohm resistor, and we have a 1.24 mega ohm resistor, so that should pull the voltage to about 6 volts, I believe. All right, or about 5 volts coming to pin 100. This is also a very critical signal, back volt, and the shutdown, and then it will release the M on signal. All right, so that's, and the power shutdown will also go high. All right, and we need the output of the M on. Let me type in M underscore on. M underscore on. All right, as you can see, this is to where, as you can see, it's coming from here, and it's also coming from the Think engine chip on the A section, right? M on. Right, and it's coming from here. This is an error on the schematic. It's on pin 94. All right, on. This is a signal that we need to turn on the standby rails. Then the board can be triggered. So we need to check the working conditions of pin. We check pin number 94, and I'm going to go back to the original page here. So I'm going to check here first. Pin number 65, pin number 99, pin 100, pin 97, pin 96, and pin 98. Okay? Right, this one is this board, a lot of techs doesn't like to work on ThinkPad engines because they don't know the working sequence of the board. Right, so I'm going to check under the microscope now for these voltages. So I'm on the Think Engine chip here, as you can see. Alright, so first I'm going to check the main input. Alright, so the main input pin, anybody remember? Alright, the main input pin is pin number 65. I'm just looking at the schematic. I already show you, so I don't have to go back to the screen. So pin 65. So this is a 128 pin, the same size of a normal embedded controller. Right, so this is pin number 1. Mark, we have 32 here, right? Pin 64. We have pin 65, as you can see. I have 19 point. I have what? 19.5. Oh, let me go back there. Right, so this is pin 65, as you can see. I have 19.57 volts there. Next, I'm going to check the next pin now, which is the back volt, which is a secondary working conditions. That's pin 100. Yeah, 96, 97, 98, 99, 100. I get 7.4 volts, which is correct. I get, after going through the voltage divider, let me go back to the schematic. After going through the voltage divider, right, pin 100, so we have 20 volts here, 19 volts, which is coming through these two 1.78 mega ohm resistor, and this is 1.24, and this is connected to ground, so this is a voltage divider, and that output voltage becomes 7.4 volts that I check, right? So that is correct. So the next working condition we're going to check now is discharge, right? And then we're going to check shutdown, and then we're going to check thermal detection. So first, next I'm going to check pin number 30. All right, so let's check pin number 30. All right, so this is pin number 32. 32. All right, 31, 30. This is low. All right, let me check if it's grounded. It's not grounded. All right, so this is low. All right, next I'm going to check the next one, which is thermal detection, pin number 98. All right, so let's go back up here. 97, 98. All right, and that's also low. All right, let's check the resistance there. Let me check the resistance. 97, 98, and that's good. I get 515. Oh, I'm out of the line. All right, so that's also good. This is steps that we all have to do step by step. 97. All right, so that's good. 98 is okay, sorry, 98. So next we have shutdown. So I'm going to check shutdown now. All right, so shutdown is pin number 97. Alright, so I'm going to give power. Alright, I have 3 point. What? Let me just. I have 3.29 volts there. That's alright, that's correct. Right, so it's pulled up by 3.3 volts, as I said before in the. Let me open the schematic. Right, so as you can see, pin 97 is pulled up by 3.3 volts here. This is a linear voltage coming from the TPS 51220, right, and it is connected to shutdown, power shutdown, and it's going to use to turn off the PWM voltages. All right, so I'm going to check power shutdown now, pin number 96. Pin number 96. I get 3.3 volts, excellent, and that's high. So power shutdown must be high, discharge must be low. When the battery is full, then the discharge signal on pin 98 will be high. Right, so the discharge signal on pin 98 will be high. Next, I'm going to check M on. Right, so let me go back to the schematic. Right, to see M on. And that's, so all is well here. We don't have any over temperature. Right, shutdown is high, discharge is low, right, power shutdown is high, 3.3 volts. We have bat volt, we have input power supply. Next, I'm going to check if I'm getting M on, which is on pin number 94. All right, so this is pin 96, 95, 94, and I don't have any voltage here. No voltage here. All right, let me check the resistance. The resistance is good. Alright, so that's 96, 95, 94. Resistance is good, no output voltage. So all the working conditions is okay, but I'm not getting an M on signal. Could be that the think engine chip is faulty. Could it be that the think engine chip is faulty, guys? Anybody? Alright, so I'm not getting a short on the output pin. There's no short on 3 volts and 5 volts standby coils. Right, and all the working conditions so far is there. Let me check the EC, if the EC is shorted. Alright, so here is the embedded controller. Embedded controller is okay or not. Alright, so I don't have a short at this cap here. This one doesn't seems to have a short, no short. Alright, so good. Plugging in back the power. What? I think I get something a while ago. I think I got something a while ago, but it wasn't there. Let me give power again. You see that current jump a while ago? Let me go up some more closer. Anybody see current jump a while ago? Let me check standby. Yes, I have 3.3 volts. at the coil. You see that? I have 220 milliamp. I now have 3.3 volts. The board is on. So by touching these pins, actually turn on the CPU? Oh man. The board is actually on. What the hell? Because I was saying, well, all the working conditions of the ThinkPad engine chip is fine, right? So I'm not getting an over temperature. I'm getting the main power supply. I'm getting the shutdown, which is the enable signal. I'm getting discharge, which is low. Power shutdown, which is high. Why it's not working? All of a sudden now, it's actually working. Could it be that let me discharge this. Let me discharge the chip. Just get a full discharge. So I'm just going to discharge this chip. Alright, so I'm going to discharge it. Alright, so I'm discharging the legs. Sorry. Alright, so I'm discharging all the legs, as you can see. Making sure I'm getting a discharge. Alright, so discharging the chip. So let me clean it, because sometimes some of the solder dust can touch. Alright, so drying the chip there. I'm going to check my ping 96, which is the key signal, which is the M on, which is going to turn on the TPS 51120, which is the standby chip. Let me go again. How long have I been streaming? 38 minutes? Oh, well, I have a visitor. Okay, why? I'm on a live stream. Yeah, man, I'm on a live stream. Here, type of video. You want to video me? Yeah, drop me a video myself. Alright, see there? So we have a visitor. Yeah.
Here.
Yeah.
So this one here, I got this from somebody a couple months ago, and them said I can take it. Yeah, but I don't know. Nobody check it. I just find it back on the computer.
So somebody gave this to you to take?
Yes. This is no wrong with it.
This is a 5th gen CPU. Normally these CPU normally die.
So if it work, this now, get it yesterday. She thought it was a charger. She bought a new charger.
Buy a new charger?
Yeah, and still no.
This is a big laptop, man.
Yeah, see that? See two chargers. See the
17 inch.
original one, new one.
Well, I'm here from I found me a spin a while ago.
I'm not sure.
Where the pop button? I swear it's our doubles in my hair. I could swear here that. Could I swear some here one fan?
So,
I don't know.
sure.
So this, alright. So you want the Legion, Lenovo, eh? Oh, I guess. Yeah, boy, power up, man. I'm going to the car. The car.
Oh,
How?
yeah, this
We carry the gear, but we forget.
So,
Okay. All right, so sorry about that. So now I will plug the power. As you can see, the board is on now. So pin 94, which is supposed to be M on, is released. Interesting. So this is pin 94. So I'm going to give power. You can see 3.3 volts is released from the chip. So the chip works. So as you can see, we have 3.3 volts there, the chose I wasn't getting before. So I'm going to connect the laptop into the board into the case and see what I get. All right, so here we go. All right, so let me go zoom out a bit so you can see what I'm doing. Is this right? There we go. All right, guys. Power shutdown. All right, so I'm just connecting the basics. All right. Oh, it was held by a screw, so it's broken. Ta. Oh shoot, it's break. It has been broken. All right, good. There we go. All right, so I want the heatsink. Oh, the video mixer. And this is the fan. Fan is in. Ta-da! All right. All right, so I will just connect the switch here. Again. I see. And it's open. Gosh. Alright, so I have the basics, so let me give power now. Alright, so it's on. 600 milliamp, 500 milliamp. There we go. So that's a fix there. It's working. So just by touching the pins on the thinking the chip should fix that problem. That's weird. It had some static electricity in it, maybe, because the probes of the multimeter releases voltages when checking, especially for shorting in diode mode for the impedance. So the tip of the multimeter sends out a voltage. So I'm not sure if that is the case here. It has a static electricity that needs to be discharged. Maybe. Alright, so I'm going to finish assembling the unit. Oh, ta. I forgot to put on back this. Forgot to put it back on. This protective film. ThinkPads always have these plastic films over them for protection, like liquid spill and so forth, and oxidation. I don't like taking apart a ThinkPad laptops. They normally have too much screws, but my main technician is not working today, so I have to do all this disassembly by myself. Oh. Okay. All right. Yes, we have battery power, and it's powering off battery. We'll still have a green light here. check if the RAM was plugged in properly. Feeling the RAM slot here. See some dust particles inside. Battery charges. I think I have a problem here on this RAM slot. I see, don't tell me that's the RAM slot has liquid. The current is not jumping. So my RAM I think my RAM slot may be having an issue here. Let's try again. Oh, so we're good. Alright. Alright, so this is done. Right. Right. There are some small screws under the keyboard, between the keyboard there, that needs to be screwed in. All right, there we go. And the last one here. And we have one here. And then we slide back down these in place. All right, done. All right. All right, there we go. Press escape to continue. I think I'm having an issue here with my card. All right, so that's a done job. There we go. So this is finished. Alright, so we'll just fill these screws and move on to the next repair. I have another hour left, maybe. Alright, so I have a MacBook that I want to look at now. It's a A1278, I believe. So I have these two now that I want to look at. I don't think I've ever done an A1278 before. Old school. Charge sometimes it's written on it. It says charge sometimes. Let's see what's going on. Alright, so I'm going to plug in the adapter. Well, I'm pressing the switch and I'm not getting anything. Alright, so plugging in the MagSafe. Is this on? I'm not getting any lights. Alright, so as you can see, there's no green light. There's no green light there. Removing, plugging it again, removing it. I'm not getting any lights. This is the MagSafe light, no lights. And this is the A1278, as you all know it, 13-inch. Not sure if it's a 2011 or a 2012. I believe it's a 2012. I'll pull the back of the board, the back screws here at the case here to see if it's a 2012 or a 2011. Okay, so it's a 2011. Right, it's A202936. Right, the board number. Right, so it's an A202936. Alright, so as you can see, I wasn't getting any standby green light there for the MagSafe. So this is a 2011 board. So I'm just disconnecting the connectors and see what's going on for the board. First, let me just check PP 3.42. Let me check PP 3.42 if it is okay or not. Alright, so PP 3.42, I'm getting 160. I'm getting 165, I guess. 225 now. 234. And that's PP 3.4. $279. Alright, so I'm gonna check all coils for impedance, see what happens, and see what I get. Alright, it's coming closer. Alright, here we go. 3 volts. Alright, that's good. 117. Alright, 3 volts. 117, 5 volts. 124 PP bus. 445. What was it? 435? 437. VCC IO. Excellent. VCC SA. Good. VCC core. I get 9. And VCC GT. 16. Oh, this is RAM supply. Sorry. So this is CPU core. Sorry. And VCC GT is here. Alright. And this is RAM. Alright. So I don't find anything obvious. Let's plug in the power again. Let me, as you can see, no fan spinning, no green lights, nothing. Let me check if PP 3.42 is there. Yes, I get 3.4 volts. Could it be that the DC jack is bad? Sometimes the DC jack can be faulty, causing the The MagSafe light not coming on. Let's check if we're getting 3.3 volts. This is for the deep sleep. No 3.3 volts. Nope. Alright, let's check. So this is the EC, right? So the EC is here at the top edge of the board here, the bottom edge of the board rather, right? And I'm not. This is what requires us to get the green light, right? So once it gets supply, reset, and clock, right? It will configure its GPIO pins and then issue the sys1 wire signal so that the embedded controller can read the information or the contents of the adapter. Right, so this is an Apple specification, right? Just like the Dell with the PSID circuit, right? So Dell, Apple, ProBooks, HP ProBooks only uses the center pin. So the center pin for this one is for the sys1 wire, which is allowing the SMCR, the EC, to read the information of the adapter to confirm that it's an original Apple adapter, and then the charging will initialize, right? So this is the order. Right, so next I'm going to check the charging IC. So I'm going to go under the microscope. Okay, camera 1 is out. Alright, so going under the microscope. Alright, so this is the charging IC. So the charging IC, which is this ISL 6259. So I'm going to check the input supply line here. Where is that glare coming from? It's coming from the outside. Alright, so this is the power. I get 587, that's good. Alright, we have these resistors here, which is for the adapter current sensing. Right, they always go bad, they should be 10 ohms. Right, this is something I repaired many times over the years, so this has become muscle memory for me. So I don't need schematic for certain types of repairs on these boards. Right, I get 10 ohm on that one, which is positive, and negative. I also get 10 ohm there, which is okay. Next one, which is here, which is 0 ohm. This is a 0 ohm resistor here for the battery sensing, and I get 0.8. So that's excellent. So let me see if I'm getting. So I'm not getting PP bus. No 12 volts, and there's no short. Alright, here we go. Alright, so the input, I get 19 volts, which is correct. This glare, oh, it's coming from my lights. I see, that is causing the glare. Alright, so I'm getting 19 volts here. Right, so pin number 1, 2, 3, 4, 3. I get 4.7. This is adapter input, 4.7 volts. This is adapter insertion, AC in. Alright, so pin number 13. So that's pin number 1, 2. Oh, sorry, I wasn't showing you on the camera. Alright, this resistor here is for adapter input, 4.7 volts. That's excellent. Alright, and I get main power supply DC in. Pin number 3 is AC in. Right, pin number 13. 1, 2, 3. Am I focused? Yeah. Right, so pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. 3.3 volts is there, pulled up from here, and I'm getting that. Next, I should go all the way up here now. For AC OK. Alright, so pin number 4, 5, 3.4 volts here. right? This is a OR gate, it's an AND gate. I get 3.4 volts there, right? Pin number 1 and 2, 0.6. This one, 0.6. Pin number 4, 0 volts. Why am I getting 0.6 here? Now I'll need a schematic. Right, so pin number 1, 0.6. Pin number 2, 0.6. Right, pin number 5 is the power supply for the AND gate, and pin number 4 here, which is the output, so I'm getting 0 volts. So let me check the resistance on those 2 pins. Yeah, pin number 1, 31. Pin number 2, 31. Pin number 4, well, we have a short here. So this is shorted. So let's go for the schematic for this board. Alright, so I'm going to close. Nope. I'm just going to head over to the Shinjaja account. Alright, I got a call, so I took a call, right? Okay, so I'm going to go for the schematics. I'm going to log into the Shinjaja. Alright, so, hey, Windows is activated. Alright, so it's 820 hyphen 2936. Yeah. All right, so I'm going to go for schematic and board view. Hold on, let me. I will activate Windows in the future. I had this set up yesterday, so I didn't remember to activate the Windows. All right, so yeah, so this is, as you can see, we have U6901. As you can see, we have SMC underscore BC underscore OK, right? And that's coming from our charging chip here that I checked, right? So pin number 14, right? And it's coming to the SMC or the EC, and it's coming to here. At the same time, this is going to output 3.3 volts, and I'm getting a low reading here. And this is the main supply, which is PPP 3.42. So this is having an error, and this is having a problem because I should get in 3.3 volts here. The reason why, because we have a short here. So look in here. This is the chip that is responsible for talking to the charger. So the sys1 wire circuit is going to come to this pin, to this chip here, right? Sorry, adapter sense, and here we have sys1 wire. So the sys1 wire, as we all know it, is coming to here. This is the AND gate that I was checking, right? So we have A, B, and Y. So we have PP3.42 at pin number 5. Pin number 1 and 2 should be 3.3 volts from the charging IC, and then it will output the high level of SMC underscore BC underscore ACOK underscore VCC to this adapter input sense chip, right? So the sys1 wire can work, right? So this is a pull-up line, and this is 3.3 volts here, 69 R6929, and this will talk to the adapter. The adapter will communicate through this wire, right? And then it will send to the EC. This is for one wire over voltage protection, right? And it is connected to the adapter. Right, so I'm getting a short here. So could it be that this chip is bad? Here, this chip. All right, and that's coming to pin number 1, 2, 3, 4 of this chip. All right, so pin number 4, as you can see here. So I will check it. It's on this side, so here it is. Alright, so pin number 4. It's okay. Alright, this is ground. And this one, that's not connected. So we don't have a problem. So could it be that this regulator itself is bad? This AND gate, sorry, right? This AND gate, could it be that it's not working? It's shorted, because on the output pin of pin number 4, I'm getting a low reading. And oh, it's okay now. What the hell? I was getting a short reading here. Let me connect the charger. I was getting a short reading there. I'm going to replace this adapter connector. I'm going to replace this adapter connector. I'm gonna put a new one. Most times the DC jack here can cause the green light not to glow. So I'm gonna try another one. Alright, so here we have, don't want to mix it up, so I'll put this here. Okay, so here it is. Alright, so I'll connect the adapter now. And I'm still not getting a green light. As you can see, the current there, it goes to 20 milliamp. As you can see on the DC power supply there, I get 20 milliamp, and that's it. So I'm not getting any lights, so it's still the same phenomenon. It's the same thing. Going back under the microscope. Alright, so I'm checking with this adapter here, DC jack. Hey, where the hell that comes from? Trying another one just to make sure. Still no lights. Alright, so I'm just going to continue checking here. Oh yeah, here we go. Alright. Alright, so I'm gonna check on this side. So here on this AND gate, I wasn't getting the voltages. Here should be 3.3 volts and I'm getting 0.6. Output, no voltage. Power supply, 3.4 volts. Going back to the charging IC. Right, pin number 13. I get 3.4 volts. Something is pulling down this part of the circuit. Could it be that the EC is bad? Anybody? Could it be that the EC is bad? Anybody? Anybody wants to participate? No one? Alright, this is the EC. Okay, I will now check back the resistance on this AND gate. 521, it's okay. Here I get 78, it's increasing. Alright, so let's go to the board view. So here, SMCBC okay. Alright, so the first part, this is coming to the embedded controller. As you can see, U4900, which is the embedded controller, the EC. Right, we also have another path, which is here. I already checked here, and oh, we have another resistor here. We didn't check this one, so let's check on that resistor there. And it's right over here. Alright, so right here. So this is the pull-up line, and this is SMC, BC, AC, OK. Alright, so that's our cap here. That's a resistor here. Alright, let's go. Oh, my L. So it's right here in this section here. It's right here. All right. So it's here. .3 volts. Yes, next side. 0.6. If I force this to ground, if I force this with a jumper wire, it will work, but the battery will not charge. If I force this with, if I run a jumper wire from here to here, the battery will not charge, but it will turn on. Let me show you. So I'm going to jumper wire. So it will work, but the battery will not charge. Remember, it says charge sometimes it doesn't charge. So I'm going to just run a jumper wire. So let me just tin here with some solder. So I figured the SMC is faulty. The SMC is most likely broken. Look, the fan will spin. We're gonna get lights. Oops. Still didn't work. So even though I forced it, it still didn't work. Still doesn't work. No lights. Let me try another plug. Normally this works, but it doesn't charge the battery. And still no lights, still no fan spinning, still nothing. So I will replace the SMC. I'm going to remove the SMC and I'm going to see if the voltage will be generated. Let's check if the 3.3 volts is coming to the let me see if the 3.3 voltage is coming here. Oh boy. Alright, so pin number 1. Still no voltage. So even though I jumped it, I'm still getting 0.6 volts and still no voltage output. It's not coming in. Oh god. I jumped the wire on the wrong. Sorry guys. It was my mistake. I jumped the wire on the incorrect path. This is the wrong resistor. This is the wrong resistor. Let me take this call. It should be this resistor, this one. I put it on the wrong one because I was saying, "What? Hey, this should work. It should have been working." This is the resistor, guys. I was on the wrong resistor. Oh, shoot. All right, there we go. All right, now I should get the green light. Let me zoom in now. And should see the fan spin, but the battery will not charge. Ah, there we go. I have green light. Now the fan spins. Take a look at the current. It's now fully on, right? But the battery will not charge. I guarantee you that. So it's fully on. I can use it as is, but the battery will not charge. See? Fan is spinning. All right. Now let me get the battery. Whoa. All right, so I'm taking out the battery. I need a special pentaloop screw for this one. Let me get it. Can the battery charge, guys? Let's see if we get the orange light and see if we get some charge current. All right. All right, so I have green light and it's now orange. Will it charge? 1 amp, 1.1 amp, 1.2 ampere, 1.3 ampere, 1.4. It's charging. Let me turn off the unit. Let me power off. One, I can't see. Let me power off the computer. And it's the 5th pin. So that's 1, 2, 3, 4, 5. Alright, so I'm turning off. Alright, it's now off. As you can see, the fan is stopped spinning. And it's charging. This is the first time I'm seeing this. The laptop is charging. The battery is charging. So as you can see, I'm getting 1.2 current here on the DC power supply. And it's in off condition. Right? Right, so as you can see, the fan is not spinning, so it's off. And I'm getting 1.2 ampere of current. So I'm going to trigger. And it's on, and I get 1.9. On a normal charging current, it should be 3.5 ampere when the battery is charging. And the laptop is on in an on condition. And I'm getting approximately 2 ampere, roughly. So the battery is charging. As you can see, I get orange light on the DC jack. I get the orange light there. And I get I'm now at 2 ampere. As you can see, so the battery is charging. So it seems that the resistor was definitely bad then. But I don't have to change it. It can work in it. So I'm going to turn off back the unit. So I'm 2 ampere. I'm going to power off. Alright, it's now off, so I'm back to 1.2 ampere of current there. Alright, so I'm on the way. Alright, so I'm going to fill it up. Alright, so this one was a bit interesting. Oopsie. These clips normally loose. The RAM always keeps sliding out. You have to be careful there. Oh, they didn't connect the mic. All right. Alright, so I'm going to connect the battery. Let's see if I can power from battery. I'm getting no power from the battery. Alright, so I'm connecting the MagSafe now. Yeah. There we go. Alright, battery charges. I think I have an issue with the cabling here on this one. Now I'm getting 2.2 ampere of current there, and the battery is charging. So that's a good job there. That's good. I think I did a good job. Well, I did a good job, innit? I did a good job, yeah? .2 ampere of current, and battery charges. And the fan is quiet. The fan is not spinning fast, which is good. I'm just waiting for it to fully load up, and then I'll see if I can fix something else. There we go. We have the login screen there. I think this is Samona or Sequoia. Sequoia? Is it Sequoia? These machines weren't designed for Sequoia or Samona, but they use the home core legacy patcher to install the latest macOS on these 2011. This is a 2011 MacBook, and they're installed Sequoia, which is not recommended. Anyway, I'll shut it down, and the battery is charging, as you can see. Alright, so that's a done job. So I'm going to, so it's fully off now, and it's back to 1.2 ampere. So the battery is charging, and that's what I want. Alright, so I'm going to do another repair if I can. I don't think I have the time, do I? 157. I don't think I have the time. I have to go on the road shortly. Alright, so let me put the back cover back on, and I will close the stream. Okay. These are not the correct screws. These are rather PC screws. So I'm putting back them as the way I saw them. That's how I got them. Alright, so this is a done job. And I will conclude the live stream now, since I was streaming for 2 hours and 17 minutes. I'm going to go on the road. I'm going to watch some movies now. I'm going to have a rest and enjoy the rest of the day. Alright, so see you in another video when I will do another repair for you. Alright, bye.